And I want to thank everybody for taking the time to attend this talk today. And before I get started, I'd like to go ahead and thank both Lisa and USENIX for giving me this opportunity to talk to you today. As Brandon went ahead and said, I'm the chief scientist at Formularity. Formularity is a relatively new company. You may not be familiar with us. Our concern is about the collection and protection of very sensitive personal health, finance, employment information. Our clients use our forms to go ahead and collect this type of information, and we design those forms and the technology in order to actually go ahead and protect that information to the best of our ability. Which kind of brings me to the subject of my talk today. And I will apologize, this is a new talk. I will be referring to my notes a little bit as we go along here. Hopefully I won't be too, down reading it from, but, okay. The news is filled with all the breaches that occur. Morgan Stanley, TJ Maxx. I can't even keep track of all the different breaches that we've seen lately. And everybody sort of supposes that those breaches occur because of a vulnerability. Somebody subverted the process, and that's how that information was leaked. Well, as Brandon said, I'm here today to go ahead and remind you that information isn't leaking because it's being subverted. Information is leaking because the processes that we use today to protect that information are broken. And I'm not telling you all anything new out there. Everybody in this room will leave this room going ahead and saying, I knew that before Brad told it to me. But I'll also go ahead and tell you that after you leave this room, I will have told you ways that you can correct this. So if you ever have to go to court and somebody says, did you do your best to protect that information? You decide how to answer that question, because I'm going to go ahead and tell you how to fix the problems that we've got today. Okay, so here in the United States, we have sort of two gold standards for how information should be protected. We have the Health Insurance Portability and Accountability Act, good old HIPAA. For everybody that's a U.S. citizen, or here in the United States, you're well familiar with it. There's also the payment card industry. They both go ahead and say encryption for data in motion, encryption for data at rest. They provide us essentially with a safe harbor. If we have a breach, we can go ahead and say, we were following government-defined best practices. We were encrypting the data when it was transmitted. It's an Ssl connection. We were encrypting the data when we went into the database because we've got encrypted file systems and we've got Oracle running on top of it, or maybe we actually paid the extra money for one of the database vendors' transparent data encryption technologies. Okay, so I'm a coder, or I was a coder years ago, and I sort of see things through a coder's eyes. And one of those is testing, testing, testing. Not testing the obvious conditions. You can test if it's positive, you can test if it's negative, but what happens if it's zero? The edge case, the boundary case. What happens when you add one more to the overflow of a numerical representation on a computer? What does that do to your application? So I'm always interested in the edge conditions, not the general condition. So data in motion, data at rest. What happens when the data stops moving and starts resting? HIPAA, PCI, they're all silent on that. Now, I'm not going to get into that right now, but we are going to go ahead and come back to that. Okay. How many different ways are our current data protection policies broken? Let me count the ways. And I'm going to try not to be too monotonous, but you're going to get tired of seeing all the different ways information is leaking. Okay, so let's go ahead and take a nice simple scenario. We've got our user who has to fill out some company health insurance forms. Because it's company related, they're allowed to go ahead and do it on company time at the office. So they're in the company infrastructure and they're using it according to the acceptable usage policy. And our user, he or she is a very smart user. They know that they should only fill out forms if the little green lock shows up in the browser. And when they got the notice from the insurance company that they needed to fill out this form, they didn't click on the link that was in the email. They're too smart for that. They manually typed in the URL just like you're supposed to. They verified that they had spelled it out correctly before they hit it. They weren't, they're looking out for a watering hole attack. So, things should be pretty good, right? Okay, before the information's even made it off the PC, the SSL connection is broken. This company uses an antivirus suite that does web monitoring. And the way that it does that is that as part of the installation process, the user accepted a bogus signing certificate from the antivirus company. That then allows them to go ahead and generate on the fly SSL certificates for any destination that the user has in mind. So here's a practical example. And believe me, I'm not picking on Avast. Just I happen to have it handy and could go ahead and do the screenshot of it. But here's a perfect example. I don't think Accenture uses Avast for their digital certificates. In fact, I'm a former partner with Accenture. I know that we used DigiCert. Okay, so the only way I found that out was by going ahead and clicking on the link and then saying, which by the way said secure connection. Then I had to click a second link that went ahead and told me to show me the actual information about the certificate. And that's when I found out that I don't even really have a connection back to Accenture. I've got a connection only to the antivirus on my computer. Okay, antivirus, good. But it's complex. There are mistakes. If I were a malware writer, I would write something to exploit the antivirus. I mean, let it do the heavy lifting, and I'll go ahead and skim the cream off the top. Or if I want to do it the hard way, I'm just going to go ahead and write a malicious program that does the very same thing the antivirus does. Okay, so leak number one. Okay, leak number two. We're talking about a company. We're talking about a large company. Who all works for a large company here? Okay, well, used to. Okay. So one of the things that and by the way, I'm going to try to keep everybody awake because I know we're on low blood sugar right now, and we're getting ready for lunch. So I'm going to ask for lots of hands up along the way. We're going to do jumping jacks as we go along. Okay, so this company is concerned about data loss prevention. They want to be sure that nobody's sending their movies or their entertainment out of the company. Sony could have used this. Okay, so they use the very same technique that the antivirus does. All of their machines are equipped with a bogus signing certificate that allows an enterprise application to break the SSL connection and go ahead and look at the packets inside, deep packet inspection, without the user ever knowing that the SSL connection was broken. These are legitimate companies that do this. Blue Coat, Intel. Again, I'm not picking on these companies. This is so prevalent that the IEEE now has a special advisory working group, which I'm part of, representing Formularity, where we're coming up with best practices for how to do this type of SSL encryption, or interception rather, encrypted traffic interception. It's happening. We should probably put some standards around it. That's what the IEEE is saying. I personally am concerned because when my client uses my product, what happens at that data loss prevention decryption, they get an encrypted payload and they can't see it. And I don't want the IT department to go ahead and say, just dump it. If we can't read it, dump it. I want a whitelist. I want it to say, okay, if it's going to our health provider, allow it to go through even though it's encrypted. Now, this is probably not a serious threat. Okay, who's in the IT department here? Yeah, okay. You got any spare time on your hands? Yeah, no. Except maybe you're having lunch, and maybe there's that executive that you don't quite like, and you're kind of interested to read the embarrassing health issues that he or she might have. So, you know, we'll just leave it at that. You don't post your salaries on the open bulletin board at work. Don't post your health information where everybody can go ahead and take a look at it. Okay, leak number 3. This particular company uses an ISP that decrypts SSL connections so that they can do bandwidth reduction. What they're doing is they're looking for images that they can go ahead and reduce. They're looking for uncompressed, un-gzipped web traffic that they can then go ahead and gzip. Or at least that's what they tell you. What they really want to go ahead and do is they want to insert super cookies and they want to insert advertising into your SSL connection. Anybody here from Verizon? Okay, Verizon, I am talking to you. Okay, this is not a hypothetical attack. At least 2 major carriers here in the United States have been caught doing this. Okay, leak number 4. The health insurance company uses a content distribution network. That's a good thing. It gets your content very rapidly to the end user. And you can also localize the content based on where the user is coming from. This particular content delivery network, and this is a real content delivery network, they offer 3 different options for doing their content delivery. Full SSL at the bottom there, which says that you have to have a SSL certificate on your site, the health insurance company's site, that is an authentic SSL certificate for that site. And then they will go ahead and essentially echo that to the end user. Then they offer full SSL, which just goes ahead and says the customer of the CDN has to have an SSL cert on the front end of their website. It doesn't have to be a valid cert. It can be a self-signed cert. But there has to be something there so that they can establish an SSL connection. Their third option is flexible SSL. They don't require their client to have an SSL certificate on their website. So health insurance costs are rising. It's probably the most lucrative business today. So what they do is they tell us that they are doing everything they possibly can to reduce the cost of healthcare and healthcare administration. So the CFO has just discovered that he can avoid having to pay for all those certs on the front end of their web server if they go with the CDN's flexible SSL connection. Now the IT department has said, no, all this information is going to be unencrypted. You don't have an SSL connection. The CFO says to the CEO, I don't know what the IT guys were talking about, but I just went ahead and saved us $1 million a year. So he doesn't understand certs, but he does understand money and savings. So again, you can see the vendor in my diagram here. I am not picking on Cloudflare. In fact, Formularity applauds Cloudflare for the work that they are doing right now to secure the net. However, they do offer this flexible SSL option, and I've seen in the wild that being used to essentially subvert the process. So again, it's not a theoretical. There are companies out there right now that are saving money by not putting SSL certs on the front end of their websites, and they're letting Cloudflare go ahead and handle it for them. And there's unencrypted traffic then going across the world. Okay, it's getting boring. Leak number 5. Okay, this website, this health insurance website, is hosted in a hosting provided data center. All the network traffic that comes into that data center goes to a load balancer with an SSL accelerator. What that means is that all of the SSL connections are decrypted by a dedicated box at the front end of the network. Now, this used to be a big thing because SSL connections, oh, and by the way, when I say SSL, I hope everybody realizes I'm really talking about TLS2 or TLS3, just everybody kind of knows the general SSL. So, used to be fairly computationally intensive. Intel and the other hardware manufacturers have actually gone ahead and put a lot of that right into the processor now. So it's not as computationally intensive as it used to be, but still, it's a general practice for a lot of hosting providers to decrypt all the traffic at the front end using a dedicated SSL accelerator. Okay, so you can see in the diagram, we got a fairly heavy black line up until we get to leak number 5, and that's because that's SSL traffic. But from leak number 5 all the way back through the web server and through the database, that's a thin line. That's plain text. So here are some of the advantages that you get from, or at least the advantages that are sold as to why you want to go ahead and do this. Also, the hosting vendor wants to go ahead and do this because this allows them to better manage the traffic flow. When they can go ahead and see what's in the traffic, they can actually go ahead and put cookies onto it so that they can do sticky load balancing. Gives them a lot more flexibility. So they want to go ahead and decrypt those connections right at the beginning of the data center. Okay, at this point now I've run out of room. I have to start, we're only going to see a part of the diagram because we've got so many leaks going on right here. Okay, within that data center, your traffic is getting routed through a number of different switches. All of those switches have spanning ports on them for diagnostics and troubleshooting. It's not encrypted anymore. Anybody can walk up to that spanning port, plug in a sniffer, and they've got all of your traffic. Okay. This is getting too monotonous even for me. The problem is leak number 7. In this particular data center, as with almost every data center these days, the health insurance website is not running on a dedicated physical machine. It's running on a virtual machine. Now, it used to be a good thing. We always used to think of virtual machines as giving us isolation and protection. NSA did a lot of work on virtual machines as ways of protecting information. Unfortunately, there are 2 givens. 1, hardware is complex and complexity leads to errors. And 2, hackers are clever. So, anybody here heard of Rowhammer? Yeah, it's in the news. Flip feng shui, that's actually applying Rowhammer to go ahead and get the encryption keys from one virtual machine, stealing encryption keys from one virtual machine, from another virtual machine. Okay, so now, hardware vendors are going to change the design of DRAM so it's not subject to this anymore. Operating system vendors are going to go ahead and use advanced address randomization so that they can go ahead and defeat this type of attack, the flip feng shui attack. But hackers are clever. They're going to figure out other ways of penetrating virtual machines. So a virtual machine is no longer protection. In fact, right now, a virtual machine is basically a recipe how somebody on another virtual machine on the same physical server can go ahead and penetrate your software. Okay. This is the modern data center. It's a hostile environment. You are in a hosting environment with thousands, if not tens of thousands, of potentially hostile other users. Now, this has all been talking about those things that we know about. Now, it's come to light recently that there are perhaps both foreign and domestic agencies that might be going ahead and subverting the very hardware that we use. So we're not even going to talk about that. Here's your biggest problem. The gentleman on your right is your new system administrator. Okay, I've been a system administrator. Good majority of the people that are attending LISA today are system administrators or have been system administrators. I do not in any way want to disparage system administrators. 99.9, probably 9% of us are good, dedicated, trustworthy, employees. But there are a few rotten apples out there. Money talks. Those people will listen to money. This isn't hypothetical. We know of bad system administrators that have gone ahead and taken advantage of their position in the data center to steal information. Government-sponsored report on insider threat in the private sector. And I get a good laugh out of this one because they're picking on the private sector. Like, they got a good track record? Here's our rogues gallery. Okay, so these are people that as part of their job, they get routine polygraphs. They've had in-depth background investigations done on them that are periodically renewed. And for money or principal, they have gone ahead and compromised the information that they were sworn to protect. So now at this point, NSA's got a pretty bad track record. You would think that they would go ahead and do something about their insider threat leakage. Can anybody see the date on this? October 5th. So just, 2 months ago, they finally determined that all of the NSA hacking tools that got released to the shadow brokers were because of a system administrator from a defense contractor working for NSA. So NSA, knowing the problem, still can't go ahead and solve it. How many of you have to go through routine polygraphs? How many of you would allow your company to do an in-depth background investigation where they want to know all the details about your childhood? So you don't have a prayer of going ahead and keeping the insider threat, keeping your system admins totally honest. Okay, let's go back to that transition from data in motion to data at rest. Data at rest. There are sort of two different ways of having an encrypted database, we'll call an encrypted database. First of all, you can handle the encryption yourself. That's where you go ahead and you take certain columns and you encrypt them. And that could be a function of the database, or that could be the function of your own application development. This is an example that we've got right here. This is where you go ahead and, no, you don't encrypt the password. We already know that. You hash the password. But this is where you encrypt the credit card number, or you encrypt the social security number. But the rest of the information is there so that you can still do selects and queries and updates and whatnot. Okay, so this has some problems. How do we get the key to do the decryption and encryption? The best way to do it is with a hardware security module, an HSM. So that'll generate the number, the key, randomly with fairly good security, and it will store it. But eventually, it's going to have to give it to the database. So eventually, that information is going to transfer from the HSM to the database. And when it does, that's when it becomes exposed. Okay. Additionally, most hosting vendors don't allow you to have HSMs. They don't have provisions for you to attach real hardware to their network because, after all, they're doing everything virtually. We could go ahead and transmit the keys through SSL. Have you all been listening to me for the past 20 minutes? Okay, so that's out. And I don't care how it gets transmitted. It's always visible inside the database process. So I'm just going to do a rowhammer attack from another virtual machine, and I'm going to go ahead and read the keys out. Here's another way of going ahead and doing the encryption. And this is where you basically go ahead and you encrypt the entire table space, or you encrypt the entire file system and you run the database on top of it. So when the database is running, that layer is going through a decryption, or that encrypted, those files are going through a decryption layer. So the database doesn't have to be changed. You don't have to make any changes to your application, but the information is always being kept encrypted. But nothing's changed. Where do you get the key from? How do you store the key? And then the key is always visible within that decryption layer. So, having an encrypted database, it's interesting, but and it's good for your backups. Nobody can go ahead and steal your backups if they're encrypted as you go ahead and run them off. It's good perhaps somebody coming in through the front end trying to hack your system, SSL injection attacks, things like that. But as far as the insider threat goes, somebody who really wants to get your information, nada. Okay, so I have spent a fair amount of time now talking to you about the problems. Now, did I tell you anything you didn't already know? I promised you I wasn't going to teach you anything in this class. Okay, so how do we solve the problem? Two things, just two things will go ahead and help this out tremendously. One of those, again, when I flipped the slide, and I already did flip the slide, so you've already gotten a preview, and again, I apologize, that's because I'm just learning this talk. But one of these you're going to go ahead and say, duh, that was obvious. And the other one, now the other one's a bit of a magic trick, so we're going to get to that one, and there's our silver bullet. But let's go ahead and take a look at the first one here. That is encrypted payloads, end-to-end encryption. So encrypt it in the browser, encrypt it in the desktop application, then send it through an SSL pipeline. It's not an either-or situation. It's a belt and suspenders. Use the protection of SSL, but then also go ahead and use the end-to-end encryption, the encrypted payload. Because that solves all the leaks that we have with SSL, and that solves the SSL accelerator problem, and that solves the internal switching within the data center problem, and that even goes a long way towards solving the virtual machine problem. So, why don't we do that? Well, for one thing, we haven't always had the tools to allow us to go ahead and do that well, but now we do. Single-page applications. So we have transitioned with AJAX, we transitioned from browsers just displaying HTML pages to actually being able to go ahead and run programs. AJAX has now transitioned into what we'll call the single-page application. Okay, let me diverge for just a moment. It is good to be old. We are now going back to client-server computing. Been there, done that, have the t-shirt. Some moth holes in the t-shirt, but they're there. Okay, so we've got applications now in the browser that can go ahead and do the encryption that we need. We've got support from the browser itself. We've got the crypto object. The crypto object will, in modern browsers, will actually go ahead and do the encryption for you using certain algorithms. If you're outside the United States, you may not trust those algorithms because of where they originated from. So the crypto object may be of limited usefulness to you if you're from outside the United States. However, the one thing the crypto object does give us is good random numbers. So please, please, please use the crypto object for your random numbers inside the browser as opposed to trying to come up with a solution on your own if you're operating with a modern browser. We have elliptical curve cryptography. Whoops. Elliptical curve cryptography, which has gone a long way to allowing us a lot more flexibility than the old RSA product of 2 primes type of public key encryption. It allows us, for one thing, to do ephemeral Diffie-Hellman key exchanges very quickly, very inexpensively. Okay, crypto is easy. I don't care what people tell you, crypto is easy. I've written my own crypto routines. Good working crypto is hard. Okay, Peter Gutmann of fame of, erase the disk 33 times in order to get rid of all the information and whatnot. He is a crackerjack cryptographer, and he has developed a crypto library that is second to none. Unfortunately, it requires the developer to make a number of different choices. And Murphy's Law, given A or B, you always go ahead and tend to make the wrong choice. So Gutmann's library is great, but it forces the developer to make some choices that may not be the right ones. And he may end up, in fact, creating laughable crypto instead of strong crypto. But fortunately now we've got people like Daniel Bernstein that have put together LISA16. And we've got the group out at Stanford that's put together the Stanford JavaScript crypto library. They have specifically said, we're going to try to make crypto easy for the developer because we're going to take all the choices away from the developer. We're going to go ahead and preload the system with all the right choices and whatnot. So again, if you're going to do cryptography, please, please, please use one of the crypto libraries like LISA16 or SJCL. My privacy may depend on it. Okay, as I said, we don't want to get rid of SSL. SSL gives us belt and suspenders. It also significantly increases our authentication. Okay, Archimedes is often misquoted as having said, give me a lever long enough and I'll move the whole world. One of the more what they believe to be accurate translations is, give me a place to stand and a lever long enough and I'll move the whole world. The problem is having a trusted base to start from. Once I've got a trusted base, I can build off of it. SSL helps me establish that trusted base for getting the initial software into the browser. And from then, I can go ahead and take it. I can use digital signatures. I can use hashing. I can use all sorts of things to authenticate the information after it's come from the trusted source. Also, I've got 2 smoke detectors in my house. They're totally independent of each other. It gives me twice the protection, I believe, from a fire. SSL and end-to-end encryption give you twice the protection. Okay, let's go back to our database question of what happens when data goes from motion to rest. Who here is familiar with homomorphic encryption? Good. Oh, this is excellent. This is excellent. Okay. Who saw Dr. Perlman's talk just before this one? Even better. Okay. Is Dr. Perlman here? Thank you. Thank you. Okay. And I was sitting with another Formularity member here. And as you were giving your talk, I'm going, yep, yep. Completely correct. Craig Gentry proved that full homomorphic encryption was possible, but just totally impractical. And I agree, things are getting better and better and faster, but when you're talking those order of magnitudes, it really doesn't matter. Okay, but I will go ahead and say that was kind of damning with faint praise. So full homomorphic encryption is still way out of our reach. But there's, aptly named, somewhat homomorphic encryption. And that's using specialized techniques. And I will not pretend to know nearly as much as Dr. Perlman does or Dr. Popa at MIT know. But I do know that Dr. Popa at MIT has gone ahead and shown me that there are ways of doing different types of encryption, taking the same value and encrypting it several different times in several different ways that will allow me to go ahead and use a proxy between my data and my database so that information in the cloud never is decrypted, and I can use a database to go ahead and do all my selects and my queries and whatnot. Okay, so MIT has out there right now Cryptdb, which is an experiment that they went ahead and did. They basically put a proxy, a homomorphic encryption proxy, in front of an unmodified MySQL database so that all of the information at the browser, at the front end to the proxy, and the proxy sits on your side of the cloud, goes ahead, it's encrypted, and it's stored in that MySQL database that's in the cloud. So this kind of neatly solves our problem from insider threat because the keys are never in the cloud. Okay. Their statistics went ahead and showed, and by the way, MIT is a very heavy user of WordPress. They have thousands of blogs out there. All the professors, all the students, all the organizations, they all have WordPress. They're all using one big instance of WordPress that MIT runs. They're all running against one set of MySQL databases that MIT runs. They went ahead and they took a subset of these and they put the homomorphic proxy in front of them, and they discovered that 97% of all WordPress queries to that MySQL database were accepted without any type of modification. And the particular homomorphic, somewhat homomorphic encryption that they were using had about a 20% overhead. Okay. They were able to solve the remaining 3% if they actually made changes to the WordPress application, so it wasn't generating the query exactly the way that the proxy couldn't accept. Okay. Interesting science experiment from MIT using a practical software, MySQL and WordPress. It's gotten the attention of people like Google with their encrypted BigQuery, Microsoft with SQL Server 2016's always encrypted option. Even SAP HANA now has a homomorphic encryption front end on it. So, and I look forward actually to talking with you, Dr. Perlman, to have a better understanding of why this is working when I accept that it's difficult. So the tools are out there. It's not just science experiments. I, again, would urge you to go ahead and use these tools the next time that you need to go ahead and store information in the cloud. Okay, very quickly, there's even another technology that we're interested in, our clients are interested in. Okay, so our clients are not a client, but I'll use as an example the U.S. health insurance system, healthcare.gov. You go in, you fill out forms, 5-page form, all about the details of your health insurance needs and the people in your household and how much money you make and whatnot. And then you indicate what providers you're interested in and whatnot. HHS here in the United States takes all the information, and then they go ahead and they ship a certain amount of that information off to United Healthcare and to Aetna and to all the other Blue Cross Blue Shield and whatnot based on your situation and who you've indicated are the type providers that you're interested in. Okay, using something called proxy re-encryption, you can actually set it up so that from the cloud, without anybody in the cloud seeing keys, you can go ahead and take the information that's going to go to Aetna. You can re-encrypt it with Aetna's public key such that you can send the information off to them and they can go ahead and read that information. Again, the information was stored. It's generic information, encrypted information that's sitting up there in the cloud. Nobody's got keys to it. Without giving anything away, you gave them a re-encryption key that they went ahead and used, and now that information can be read by Aetna, but it can't be read by UHC. So our clients are very interested in the idea of being able to selectively send out information by re-encrypting it. And again, this is the work that's being done by Dr. Green at Johns Hopkins University. Okay. Did I tell you anything new? Nope. When you go to court because you had a data breach and they say, did you do everything that you could to protect that information? You can go ahead and say, well, I followed HIPAA. Or you can go ahead and be sure that your developers and your company are using these two simple pieces of technology to help better secure information. And if anybody's got any questions about how to go ahead and do that, I would be happy to talk with them about it. I'm, the lone voice out there in the wilderness that's trying to get people to go ahead and better protect the information because, like I said, it's my information that's being protected. I'm not going to worry about credit protection for the next year. The Office of Personnel Management in the United States government is taking care of that for me because they lost all my information. Okay, very, very quickly, interesting catch-22. In order to work for certain agencies in the government, you have to have a security clearance. In order to have a security clearance, you've got to tell them everything about yourself, and you've got to give them permission to go digging into your past and talk to your neighbors and talk to your teachers and things like that to prove that you're trustworthy to protect the government's secrets. And what did the government do? It lost my secrets. And the reason I bring this up is because part of the reason the Chinese were able to go ahead and get my information was because of that transition from data in motion to data at rest. The company that did the background investigations encrypted the data. SSL, when they transmitted it to OPM. OPM stored it encrypted on their database, in their databases. The Chinese read it after it came out of SSL and before it went into the database. So I'm hoping that somebody at OPM is looking at homomorphic encryption. Copy of the slides and the talking points can be downloaded from the Formularity website. Questions? Lunchtime? Thank you.